Hello, ladies and gentlemen. Now I'd like to talk about the proof for the derivative of a sum or difference is equal to the sum or difference of the derivative rule. So the rule looks something like this. If h of x equals f of x plus g of x, and if I ask you for the derivative of h of x, it would be the derivative of f prime, or the derivative of f, plus the derivative of g. So, and the same would be true if it was negative. So there you go. So that's the rule that we want to prove. So proof. Given h of x equals f of x plus g of x, and the functions are all differentiable, then what I want to show is the derivative of h of x, first of all, by the rules, by first principles, is the limit as h approaches 0 of h of x plus h minus f of h of x all over top of h. Okay, in this place, we've got h equals x plus h. Probably shouldn't use two h's, but I'm going to. And so that is going to be equal to f of x plus h plus g of x plus h. Because remember, we said h was equal to f of x plus g of x. So if I'm going to change the x to x plus h, then it's f of x plus h, g of x plus h. And h of x is simply f of x plus g of x. So plugging them back into here, we're going to get the limit as h approaches 0 of f of x plus h plus g of x plus h minus f of x plus g of x, brackets are a good thing, over top of h. This will work out to the limit as h approaches 0 of f of x plus h plus g of x plus h minus f of x minus g of x all over top of h. Rearrange this a little bit if you don't mind. The limit as h approaches 0 of f of x plus h minus, I'm going to bring that closer to that, and then I'm going to put g of x plus h minus g of x. There's a plus between that. It's all over h. Using what we know about fractions, we can change that to the limit as h approaches 0 of f of x plus h minus f of x all over h plus g of x plus h minus g of x over h. All right, now the limit of the sum is equal to the sum of the limits. We know that. That's not a derivative property, that's a limit property. I've proven that in previous areas of this course. And this, by definition, is the derivative of f of x. This, by definition, is the derivative of g of x. And we have finished our proof. QED is what we say. It's Latin. There are some teachers that will tell you it stands for quite easily done. That's not really where it's from. Look it up. Be educated. Know what it means. And it's the same proof had it been the difference of two functions. Anyway, that one's done.